Hi everyone, I just wanted to briefly cover the logic behind flipping the charges for ionic compounds. So this is of course assuming that you've already watched the video on the formulas of ionic compounds, and you see that the charge of the ions actually flips. So the charge here of aluminum becomes the number of oxygen atoms, and the charge of the oxygen, the absolute value of this, becomes the number of aluminum atoms. So why does this make sense? So we're just going to look at this in a very visual way. So we're going to just write this out, the ions with their charges. And we're going to note that up here, if there was a charge on this compound, it'd be right up here as a superscript. Our final compound has no charge, so that's going to be a really important note. So all of the charges are going to need to cancel out here because we end up with no charge. And that's really going to be the key for why we flip the charges. So we've got an aluminum ion, it's in group 3, it's got a charge of 3+, it's a cation. Oxygen is in group 6, it has a charge of 2-. So if we were to add these up exactly as is, 3+ and 2-, our overall charge is going to be +1 because there's more positive charges than there are negative charges. So that's not going to work. We're going to have to add in more negative charges to balance it out. So let's add in another oxygen atom, another oxygen ion rather, this anion. They only come in this -2 charge. So now we don't have, so if we were to add this up exactly as this, it's a 3+ and a total of 4-. So where we're at right now is now we've got too many minus charges. The overall charge, if we added up each one of these values, would be -1. And that's not going to work either. So let's add in our positive. The aluminum ion is in group 3, it only has charges of 3+, so that we're limited by the periodic table. That's just what it does. So we listen to the periodic table. So now our overall charge, as you can see, there's 6 positives and 4 negatives. That doesn't equal either. So let's add in more negatives. So here's our oxide anion with a 2- charge. And now what do we see? We see 3+ and 3+ is 6+. 2-, 2-, 2- is 6-. So this is the combination, this right here, this is the magical combination that gives us a neutral overall charge because we don't want to end up with a charge. We have no charge here, so we have to cancel out all the positives and all the negatives, and this is the combination that gets it. So let's go ahead and write out how our new formula, cation first, then the anion, and the numbers that we see. We see 1 aluminum here and another aluminum there. 1 + 1 is 2. So we have 2 of these aluminum ions. And we've got 1 oxygen, 1 oxygen, 1 oxygen. That's 3 oxygens total. So overall, we need 2 aluminums and 3 oxygens in order to get the neutral compound. And so just because of this fact, it's going to turn out that every single time that you do this, the shortcut way to do this, instead of drawing it out, because you saw it took a moment, is that you flip the charges. So that Al3+ and that O2-, those charges need to flip. The 3 of the aluminum is always going to become the 3 of the oxygen. It's somewhat similar to a common denominator problem. So thank you so much for your attention, and I hope that this has been helpful to you.